Assistant Professor, Department of Electrical Engineering, Jahangirabad, Institute of Technology. I'm immense pleased to produce this presentation via this video, and this is prepared in association with Mr. Muhammad Akram, also Assistant Professor, Department of Electronics Engineering of my college, that is Jahangirabad Institute of Technology. We both did a few days research and prepared this presentation, and this presentation is all about designing the IIR digital filter. First part of this is Butterworth filter. As you can see in this second slide, it is an analog filter approximation. This filter has a characteristic of low pass filter, and it works up to the frequency of cutoff, that is FC. It blocks remaining frequency, as mentioned in this presentation. You can see the diagram as well. The pass band is shown and the stop band is also shown. The area within the graph is utilizable, otherwise it would be blocked, as shown in the figure 1, characteristic of the low pass filter. Moving on to this approximation in ideal characteristic. It has several parts, but we have just discussed few key parts as per the diagram shown in the figure here. We have plot a graph between the frequency f and the HF, where you can see that there are different type of frequency mentioned, Fs, Fc, Fp. Relatively, we have few values in dB from -3 to 1 dB. So this works in reduction would start after it passes the band energy frequency Fp. Filter blocks all the frequencies, stop band, edge frequency Fs. Fc lies between the frequency Fs and frequency Fp. You can see that in the diagram, the delta F. The delta F is Fp difference Fs. However, in the log scale, Fc is 3 dB down to the maximum value, and 1 upon root 2 of the maximum value would be in the absolute scale. The delta F is the transition frequency from the pass band to the stop band. Figure 2 is showing the approximation of the ideal characteristic. Now, the Butterworth filter approximation, it characterizes the magnitude response of a Butterworth filter. Below is the magnitude response of the low pass Butterworth filter, that is mod h omega square is equal to 1 upon 1 plus mu upon mu c power 2 capital N. You can see in the graph shown adjacent to this presentation that we have few points mentioned there, that is stop band attenuation, pass band attenuation. The stop band attenuation is mentioned as AS, and the stop band attenuation is mentioned as AS, and pass band attenuation is mentioned at AP, where 0.5 and 1 are 4 different values, AS, 0.5, AP and 1. The graph is from 1 to omega to the stop band on the x-axis. You can see that relative values of 1 lies between the stop band edge mu s to x-axis. Salient features of a low pass Butterworth filter is, at low frequencies we have magnitude response nearly constant, all values would be equal to the 1. We will not see any ripples in the pass band and stop band. The maximum gain occurs at the 0 and 1. The magnitude response is monotonically decreasing as the order of the filter n increases. The response of the filter is more close to the ideal response. Where you can see in the graph that 3 different colors has been shown. Green is the ideal characteristic, and rest are in between the ideal and the actual characteristics. When you are going to design a Butterworth filter, you have to take some approximation. We will discuss it in next video. Thank you everyone.